Alright, this is Mike Dirksen, BCA-101, Unit 5, Communications. This would be the second whiteboard. And so this date right here, that's actually, this is Monday. And so this is covering actually about a week and a half, or some items from, oh, it wouldn't be a week and a half, it would be 2 days last week. And this would be the second of the whiteboard reviews. The topology, when we think about the topology, we have the physical topology of a network, actually like this from here to here. The PC has a cable, and it runs to a port on the table. Underneath the table, there's a cable from there, and goes all the way up to the rack, and that cable then is terminating the rack. And then in our situation, in the rack next to it is a switch, and then there's a cable from here goes through and goes to that switch. Then there's a cable from here that goes back into the rack, and then from the rack there's a cable that runs to another rack and in there, and then that one goes to a switch, which in reality is this switch right here, as an example. This switch here would be this one here. That would be physically how everything runs. So they call them cable plants, or in any business, any building, they have to decide how they're going to do that, how they're going to run the cables, where are they going to be fiber, which ones are going to be category 6 now, cable, twisted pair, and so forth. That's the physical. The logical diagram is a picture of the same thing, showing how the traffic flows, but without showing all these details. For example, we're just here, we just show from the PC we're connected to the switch, where over here we showed all those cables and eventually ended up in the switch. But in general, we just need to see this. A lot of times the logical form will have listed with it the IP addresses. We've been leaving those out because we just haven't learned much about them up until this point. Okay? So that's the difference there between the topologies, a physical topology and a logical topology, which is more what this is right here. This is the start of a logical topology. Okay, a couple things we talked about the other day. We reviewed bandwidth again. Okay, for example, in our room, in our classroom, the blue wire that connects to the switch, like I showed here, that is operating at 100 million bits per second. So every second, 100 million bits can travel through there. Okay? And, you're maybe not sending that much at any one time. But that's how it works. Then, the connection, we have another cable that connects here to here. And that's this whole process. It goes from the switch, patch panel, to another patch panel, from that patch panel to that multi-layered switch. That one moves information at 1 gig, 1 billion bits per second. So we talk about bandwidth. Okay, so we can have lots of 100 millions sending into here and easily keep the traffic moving, because here we're moving everything at 1 billion bits per second. All right. We have a PC connected. That one has to be connected at 100 million, just as an example, bits per second. And this PC is sitting in my office, and that's the work server. Okay, and that has a private address and a public address, which we'll talk a little more about in a minute. All right, so I'm going to move to the next page. That was about 4 minutes. All right, now the bigger picture here. Here at the college, we talked a little bit about a firewall. We have a firewall that stops traffic from coming in. Traffic on the inside, let's say traffic here going out, it lets it go out, and then the firewall keeps track of where it's going to Facebook. Then when traffic comes back from Facebook, it lets it in. Yeah, maybe you're on your phone and you're doing some Facebooking. Okay? So we talked about a firewall. This router over here acts as a firewall over in the IT area. Okay? Then when you go out, okay, a little more review again, we've got bandwidth. When we go out, internally we have these private addresses, the word private there, and then we have a public address. So actually that gets converted right up here. It uses something known as network address translation. So this private address is converted to the public address right here, and that public address can be used then out on the internet. Out here. Okay? Now, if you're on campus on the Wi-Fi, you need to use the open network. So here you are on your phone, or let's say it makes more sense, let's say you're on your laptop. Yeah, draw this beautiful laptop here. Okay? When you connect to the college Wi-Fi, you should connect to the open, not the guest. Okay? So use the open, and you should be able to access the work server. Via this address, because you're coming in from the outside, the 207.165.226.184. And then of course you got your password and so forth to get in. Alright, we talked a little bit about devices. We have up here, we have a router. This is a multi-layered switch, which is a router and a switch. Here we have a switch. Here's another multi-layered switch, a switch, and up here is a router that controls the traffic. The internet has all these routers that determine whether it should go to this network or what's the best path moving through. The ISPs, they connect in maybe multiple ways to those tier 1 providers. And they all talk together, the tier 1 providers. They have no charge between each other. And so all these places from the outside, somewhere is connected. Google might be its own tier 1 provider. Yahoo might be also, and Facebook might be also. All right. So another piece of networking equipment, is an access point that allows us to communicate wirelessly, Wi-Fi. And what we move through there, everything moving through are ones and zeros, arranged in a particular way. All right, we're going to move to the next page. Actually going on 8. We covered some specifics like wire, could be twisted pair or coaxial cable. A lot of cable companies are using this to get it into your house. They'll use fiber to get it outside your house, but actually getting in your house, they'll use coax. Someday it might all be fiber. A lot of telephone companies are running fiber right up into the house. I know Clear Lake's got a lot of fiber, even in town, and some of them, CLTel and Winnebago and Omnitel, they're laying a lot of fiber. Fiber can be multi-mode, shorter distances, not as expensive. Single mode, longer distance, a little more expensive. Those are two major ones, and there's other categories we're not going to worry about. Wireless, we have Wi-Fi. We have a protocol that allows us to connect to devices. There's a WiMAX protocol. It's a little bit different. Maybe like 31 miles, maybe you could connect. This would be like connecting people out in the country for internet. We have LTE, 4G, that's a G, you might not look like it. Long-term evolution, and we have that method, and it's important to understand these are all different. The same thing, if you're talking just using the cell feature, like you're sending a text, that's not going through any of those. It's not going through the internet either. It's going through the phone system, the cell system, which is typically a circuit switch system. You either have a connection or you don't have a connection. Whereas packet switching, these are all packet switching here, in which it builds a data packet with the information in it and then it sends it. We'll talk more about that later on. Email. A lot of people said, oh yeah, we know what email is, but a little more about it. When you email, like when you send, it's called simple mail transfer protocol. That's a protocol, don't really need to know a whole lot about it, but it's a protocol that allows us to send the mail, and the mail ends up on a mail server. And then at night, or maybe multiple times during the day, they create a backup of the mail server. So you come in and you say, oh, I'm going to delete that email. I don't want anybody to see. It's probably already stored on a backup device somewhere. POP and iMac are ways to get the mail off the server. So you're sitting at home and you're going to read your email. So now these protocols allow you to take that email and put it on your device, your computer, your phone, or whatever. This also, simple mail transfer protocol, also allows to send between mail servers if they're sharing the mail. One more slide left. 7, 8, 9, we're almost to 10 minutes. I'll make this quick. The internet, HTTP and HTML, that ability to use web browsers, they use the internet. You can access websites on the internet without using a web browser. A lot of people don't know how, but you could go in and you can access a site and actually look at information on a server somewhere without using hypertext transfer protocol and HTML, even though this is extremely popular. So World Wide Web uses these features, but the World Wide Web is not equal to the internet. It's not. The internet sends all kinds of traffic. The internet will move mail traffic through. You don't need a web browser to have email. It's used a lot for that, but you don't have to have it. You know, we can transfer files. We can download and upload files without using browsers and so forth. So that's just important to know. And that's it.